welcome to my channel. I am Mensa Augustine. In this lesson, we are going to prove the standard formula for the integral of secant x. That is indefinite integral. Now, if you are new here, kindly subscribe to my channel. Now, let's go to the proof. I'm going to use two approaches. You look at the longest one and then look at the shortest one. I hope both approaches will also reveal more secrets for you. Now let's take the integral secant x dx. The first approach, I'm going to use the sign substitution. Okay, so here this is the same as the integral 1 divided by cosine x dx, because the reciprocal of cosine x will give us secant x. Watch my video on reciprocal of trigonometric ratios from the description. Here, this one can be written as cosine x divided by cosine x times cosine x. So you see that if cosine x cancels cosine x, you get 1 divided by cosine x. So what do we do? So here you have cosine x divided by cosine x times cosine x will give us cosine squared x. So I'm going to write this as the integral cosine x divided by cosine squared x dx. Now from trigonometric identities, if you have cosine squared x plus sine squared x, we get 1. So if I send sine squared x to this side, I'm going to have cosine squared x equal to 1 minus sine squared x. Very simple as that. So in place of cosine squared x, I'm going to have the integral cosine x divided by 1 minus sine squared x dx. That is very natural and very simple. Now, I have videos on trigonometric identities, how to prove basic trigonometric identities. So watch that video from the description. Now let's move on. We will let u equal to sine x. That is our u substitution. And here the derivative of u with respect to x is equal to cosine x dx. If we make the x the subject, we are going to have the derivative of u divided by cosine x is equal to dx. Sorry, we are going to have du on cosine x equal to dx. Now, let us do the substitution. So here you have the integral cosine x divided by 1 minus u squared times du on cosine x. And here what do we do? Cosine x will cancel cosine x. And you'll be left with this to be equal to the integral 1 divided by 1 minus u squared du. Now, here what are we going to have? This is the same as 1 divided by 1 plus u times 1 minus u du. Then bring the integral sign. That's integral 1 divided by 1 plus u times 1 minus u du. Why? Because if you have a squared minus b squared, it is a plus b times a minus b. That is difference of two squares. So 1 minus u squared is the same as 1 squared minus u squared. So here a is 1, b is u, a is 1 and b is u. That is difference of two squares. Now we are going to decompose this into partial fraction. Now if you look at this, the denominator here has linear factors. So you write 1 divided by 1 plus u times 1 minus u to be equal to a divided by 1 plus u plus b divided by 1 minus u. Now let us simplify this. The LCM is 1 plus u times 1 minus u. So here if 1 plus u divide this, you get 1 minus u times a. Plus if 1 minus u divide this, you get 1 plus u times b. Is equal to 1 divided by 1 plus u times 1 minus u. Now since the denominators are the same, you equate the numerators. You have 1 is equal to a times 1 minus u plus b times 1 plus u. Now what do we do again? If we choose u to equal to -1, you have 1 to equal to 1 minus 1, that will give us 2 times a. 1 minus 1 will be 0, so b will be 0, so we have 1 on 2 equal to a. If we choose u to equal to +1, we are going to have this one as 1 minus 1, 0, so a will be 0. 1 plus 1 will be 2. So we are having 1 is equal to 2b, and that 1 over 2 is equal to b. Very simple as that. So in place of this, we are going to write the integral 1 on 2 on 1 plus u plus 1 on 2 on 1 minus u du. Wow, very simple as that. So here, let us factorize 1 on 2 out to get 1 on 2 times the integral 1 on 1 plus u plus 1 on 1 minus u du. So this is sum. So let us send the integral sign into the bracket. So we have 1 on 2, the integral 1 on 1 plus u du plus the integral 1 on 1 minus u du. And this will give us 1 on 2, 1 divided by 1 plus u. If you integrate this with respect to, if we find the integral of 1 divided by 1 plus u, we are going to get the natural log of u minus, if we integrate 1 divided by 1 minus u, we are going to have negative natural log of, oh sorry, this is not u. So let's do it more properly. This will give us half times the integral of 1 divided by 1 plus u is ln 1 plus u. That's the natural log of 1 plus u. And then the integral of 1 divided by 1 minus u is the same as negative the natural log of 1 minus u. Then that the constant c. So here what do we do? We are going to have this as half. Then we apply the laws of logarithm. If we have minus here, then it means you are going to divide the numbers. You are going to have the natural log of 1 plus u divided by 1 minus u plus the constant c. But this one can be simplified further, so let us simplify it further. Somebody there is asking why I got the negative sign here. Let me do that one here for you. If you have 1 divided by 1 minus u, the integral of this du, and you want to integrate, we will let u equal to 1 minus u, sorry, v. So the derivative of v will be equal to negative du. Because if you differentiate 1, you get 0. If you differentiate negative u, you get negative du. Now, if we make du the subject, we are going to have du will be equal to negative dv. So this will give us the integral 1 on v times negative dv, and that will give us negative integral 1 on v dv. And the integral of 1 on v will give us negative natural log of v. So what is v? 1 minus u. So we have negative natural log of 1 minus u. But if it is positive, du will be equal to du, and there will not be any negative sign here. So that's why we have the negative sign here. Now let's move on. Let us rationalize the denominator here. So let's do the rationalization in a simple way. Let's do the rationalization. So here we are going to have ln of 1 plus u divided by 1 minus u times 1 plus u divided by 1 plus u. Let's bring the absolute value sign, and we have our half here. Now remember that the conjugates of 1 minus u is 1 plus u. Yes. So if you multiply the top, you're going to get half ln 1 plus 2u plus u squared divided by, if you multiply the denominator, you get 1 minus u squared. Let me bring the absolute value sign. We have plus c plus c. Now, here we are going to have 1 on 2, the natural log of, let us do the substitution. We have u equal to sine x, so you have 1 plus 2 sine x plus sine squared x, that is u squared, divided by 1 minus sine squared x plus c. Now let us move on. Let me clean this side. So what will this give us? Here we know that 1 minus sine squared is equal to cosine squared. That is what we have here. We are having half ln, or the natural log of 1 plus 2 sine x plus sine squared x divided by cosine squared x plus c. Now, what do we do again? We divide each term by cosine squared. So you have half of the natural log of 1 divided by cosine squared x plus 2 sine x divided by cosine squared s plus sine squared x divided by cosine squared x plus c. Wow. Now let me stand here. Now, 1 divided by cosine squared will give us what? So you have 1 on 2 ln of the absolute value of secant squared x. As I watched my video on basic trigonometric identities and the reciprocal of trigonometric ratios from the description to understand how we are dealing with these identities. So this will give us plus 2 secant x tangent x plus tangent squared x plus c. Now, why this? Let us do some quick explanation here. Now, here 2 sine x over cosine squared x is the same as 2 times sine x divided by cosine x times cosine x, and this is the same as 2 times 1 divided by cosine x times sine x divided by cosine x. 1 divided by cosine x is secant, sine x divided by cosine x is tangent. And here if we have sine squared x divided by cosine squared x is the same as sine x divided by cosine x all squared. Sine x divided by cosine x is tangent x, and the tangent squared will give us this. So that is what we've used. And here 1 over cosine squared x is the same as 1 divided by cosine x all squared. 1 on cosine will give us secant, and the square will come. So that is why we have that. Now, for the expression inside the absolute value sign, let us take secant x plus tangent x all squared and c. This will give us secant x plus tangent x times secant x plus tangent x. Now this will multiply this, you have secant squared x plus secant x tangent x plus secant x tangent x, then plus tangent squared x. So if we add this together, we are going to have secant squared x plus 2 tangent 2 secant x tangent x plus tangent squared x. So you see that if we expand this, we are going to get what we have inside here. So I'm going to write this in place of what is in the absolute value sign. So we are going to have half of the natural log of secant x plus tangent x squared. Let me bring the absolute value sign plus c. So here what will happen? The square will come here. So you have 1 on 2 times 2 natural log of secant x plus tangent x plus c, and half of 2 is 1. So we have ln secant x plus tangent x plus c as the standard formula for the integral of secant x dx. Now, let me use the shortest method. Now, the shortest method will deal with the natural logarithm function. Now, let's say that u equal to secant x plus tangent x. This is the shortest way. So here, u prime will be given by d dx secant x plus d dx tangent x. So you have u prime will be equal to, if you differentiate secant x, you get secant x tangent x, and if you differentiate tangent x, you get secant squared x. Wow, mathematics is lovely. Here we have u prime to be equal to, we are factorizing secant out, so we have secant x times tangent x plus secant x. Now, what do we notice, or what have we noticed? We have this equal to the u that we started with. So having u prime is equal to secant x times u. Now let's divide both sides by u. We have u prime divided by u equal to secant x. Wow. Now, watch my video on the derivative of natural logarithmic function. Now you see that if we have ln of u, then the derivative of the natural log of u will give us u prime divided by u. So if you differentiate the natural log of u, we are going to have the derivative of u divided by the u. So here it implies that here, if we integrate this, we are going to get ln u. So let's make our integral sign. So we take the integral of this, and that we take the integral of this. Very simple as that. So the integral of this will give us ln u equal to the integral of secant x dx. And what is ln u? Ln u is secant x plus tangent x. Sorry, what is u? U is secant x plus tangent x. So you are going to replace this by ln, then bring the absolute value sign, secant x plus tangent x equal to the integral secant x dx. And this gives us the standard formula for the integral of secant x dx. So whether you go through the shortest way or the longest way, each one will improve your understanding and also make you a mathematician. Thank you for watching, and please subscribe to my channel. Bye bye. I didn't bring the plus c, so I've done it. That is the constant of integration. Bye bye.